Okay, let's talk BlueBorne. It's similar to Swain Tooth in that the attacker is injecting carefully constructed packets, but they took it considerably further. The BlueBorne researchers did. They were able to show remote code execution by digging through the code in the Bluetooth stack to actually get real code execution. The attack applies to the Bluetooth stack in the Linux kernel, Android, and they have demonstrations for Windows and Apple. You can check out their website for all the details. Their white paper is definitely worth a read. It's well written and informative. So they note that the Bluetooth spec is 2,800 pages. Wi-Fi is only 450 pages, and it's kind of hopelessly bloated. They note also that the whole OSI stack is re-implemented in Bluetooth, whereas Wi-Fi leverages TCP/IP and other standards. They don't try to do it all themselves. So all this complexity and packet/stack fragmentation makes it hard for vendors to properly implement the Bluetooth stack, just like we saw with Swain Tooth. So the plot on the right shows a plot from the Bluetooth spec, and you can see each time you get a new layer or a new fragmentation here, there's C code that somebody's got to write to handle these fragmentations and all the options, basically. So it's easy to miss corner cases. So what they did is you've got the Blue's code, and the kernel code is all available open source. And for the Linux vulnerability, at least, they were able to just figure out where buffer overflows were possible and then carefully craft a sequence of packets that would load up the buffer in such a way that they could get remote code execution. Specifically, they found a L2 cap problem where the buffer was allowed to be arbitrary length, even though the protocol was only using a certain number of bytes. And so they could do an overflow and get their code onto the target device. Here's a quote from the paper that highlights something that's maybe even more interesting, is that for the Linux kernel, this Bluetooth stack is actually in the kernel code. So that means that once you get this exploit, you're running code in kernel space in the context of a kernel thread. So the last sentence here, this provides an attacker with a full and reliable kernel level exploit of Bluetooth-enabled devices running Linux, requiring no additional steps. So that's impressive and super scary.